This video is for Section 4.1, Sampling and Surveys. We're going to begin by talking about two important definitions not only to this section in this chapter, but to statistics in general. The first one is population. And so in a statistical study, the population is the entire group of individuals about which we want information. So if we were doing a statistical study of the students at East Rutherford and their likelihood to eat in the cafeteria or to bring their lunch, the population would be every student at East Rutherford. So this is kind of who we're drawing a conclusion about. A sample is the part of the population from which we actually collect information. And so we use that information from a sample to draw conclusions about the entire population. So at East Rutherford, we have roughly 750 students. It would kind of be difficult to get in touch with all 750 students due to absences or whatnot. And so you might want to take a sample. And so a sample would be just a portion of those students. So you might choose to take a sample of 300. That means that you are only speaking to the 300 students from the sample. You're not speaking to the other 450, just the 300. And so we have two other examples that might help you into determining which is population and which is sample. The first one is a furniture maker buys hardwood in large batches. The supplier is supposed to dry the wood before shipping. The furniture maker chooses 5 pieces of wood from each batch and tests their moisture content. If any piece exceeds 12% moisture content, the entire batch is sent back. And so what I'm going to do is I'm going to highlight anything I think is population in yellow and anything that I think is sample in orange. And so you have to think about your population. Now remember in our East Rutherford example, the population was all 750 students that go to East Rutherford. And so in this furniture example, what is the population? What is the big picture? And so the big picture in this one would be all the hardwood in large batches. And so your sample is going to be the pieces that you are actually talking about from your population. And so in this case, because our population is hardwood in large batches, it goes on and it tells you that the furniture maker chooses 5 pieces of wood from each batch and tests their moisture content. So your sample is going to be the part where he chooses those 5 pieces of wood from each batch and tests their moisture content. Now, one thing that you really have to get used to in AP Statistics is you have to make sure that you are always writing in complete sentences that make sense and make you sound super smart. And so the solution that the book gives you to this first example, for example A, is the population is all the pieces of hardwood in a batch, and the sample is the 5 pieces of wood that are selected from the batch and tested for moisture content. And so typically in a math class, if you were given a short response type question, you might not always write in full sentences. But just to be in the good practice of writing full sentences for the AP exam, always make sure that in this class you are writing everything in full sentences and you are making yourself sound super smart and including all the extra details that you think that you might not need. For your second example, it says each week the Gallup poll questions a sample of about 1,500 adult U.S. residents to determine national opinion on a wide variety of issues. And so I'm actually going to start with sample on this one. And the reason that I'm starting with sample on this one is because it kind of gives you a hint here, and it says a sample of about 1,500 adult U.S. residents. So it tells you I'm taking a sample, I'm taking part of them, and that's the 1,500 adult U.S. residents. And so then it kind of leads you to believe that finding your population from that question might be a little bit more difficult. And so if you think about, if your sample is the 1,500 adult U.S. residents, that is the group that you are taking information from. So you kind of have to think, where do those 1,500 adult U.S. residents fit into the entire group of everybody that we would be talking about? And so this would be, they fit into adult U.S. residents. And so again, your fancy answer is Gallup's population is all adult U.S. residents. Their sample is the 1,500 adults who actually respond to the survey questions. So how to sample badly? There is a way that you can sample badly. And when we talk about sampling badly, what we really mean is that whenever you do your statistical study, there's some sort of flaw or some sort of big hang-up that keeps you from having the most accurate information. And so 3 things that are important when you're sampling badly is convenient sample. And so you want to kind of try to avoid a convenient sample. This is choosing individuals who are easiest to reach. And so if we go back to our East Rutherford example where we're talking about eating in the cafeteria versus bringing your lunch, a convenient sample might be if you stood in the cafeteria and you just talked to people that were walking by. You kind of have to think, well, if they're in the cafeteria, they have a better chance of getting their lunch from the cafeteria. And so that creates what we call bias. And so a bias is when your study systematically favors certain outcomes. And so if you're standing in the cafeteria and you're asking students whether or not they eat in the cafeteria, you have a better chance of a student saying, yes, I eat in the cafeteria, than someone who has been sitting in the library for their entire lunch period. A voluntary response sample is just kind of what it sounds like. And so it's a volunteered response. And so this consists of people who choose themselves by responding to a general appeal. These samples show bias because people with strong opinions are most likely to respond. And so this would be like if you were posting that same question about the cafeteria versus bringing your food on the Facebook page for East Rutherford. And so those of you that feel very strongly about bringing your lunch or eating in the cafeteria are going to be more likely to respond to that survey than people who are just kind of like, well, I'll do whatever I feel like on that day. An example that kind of ties up all of those vocabulary words we just spoke of is former CNN commentator Lou Dobbs doesn't like illegal immigration. One of his shows was largely devoted to attacking a proposal to offer driver's license to illegal immigrants. During the show, Mr. Dobbs invited his viewers to go to loudobbs.com to vote on the question, would you be more or less likely to vote for a presidential candidate who supports giving driver's license to illegal aliens? The result, 97% of the 7,350 people who voted by the end of the show said less likely. So the problem is, what type of sample did Mr. Dobbs use in his poll, and explain how this sampling method could lead to bias in the poll results. And so if you kind of think about the way he had people to answer the question, he invited his viewers to go to his website. And so when he invites his viewers to go to his website, there are going to be people that are watching the show that for sure go to his website and people that for sure do not go to his website. And so the type of sampling that he would use would be a voluntary response sample. So these are people that are volunteering their response. And so when we talk about how this sampling method can lead to bias in the poll results, we have to think if these people are watching his show and he tells them to go to his website, then they are probably more likely to feel the same way he does. And so this is where we kind of think about this 97% of 7,350 people. What are the chances that if you take a sample of anybody or random sample that you're going to end up with 97%, almost 100% of the people that voted said that they were less likely to support giving driver's license to illegal aliens? And so your fancy answer would be Mr. Dobbs used a voluntary response sample. So people chose to go online and respond, and those who voted were viewers of Mr. Dobbs' program, which means that they were more likely to support his views. Your notes each day will include several portions that are check your understanding. Check your understanding are where you are going to answer some examples and answer some questions that will help me and you to determine whether or not you really understand what's happening in the notes. I will be using the information that I get from those check your understanding portions to give you a grade on each section. So make sure that you are answering the questions to the best of your ability. And so for your first check your understanding, it says for each of the following situations, identify the sampling method used and then explain how the sampling method could lead to bias. And so we've talked about only two sampling methods at this point, a convenience sample and a voluntary response sample. Remember that a convenience sample would be like you standing in one place and talking to just the people that are around you, not really reaching out to anyone further than where you are. And a voluntary response sample means that people are volunteering or coming to you to respond to whatever question you answer or you ask. So what's going to happen is I'm going to read the first example. When I finish reading the first example, a question will pop up. You answer the question, and once you answer the question, it will move on to the next part of the video. So in number 1, it says, a farmer brings a juice company several crates of oranges each week. A company inspector looks at 10 oranges from the top of each crate before deciding whether to buy all the oranges. So again, remember that we talked about two types of sampling methods. Now your first objective is to identify the sampling method that was used. And so we talked about convenience samples, standing in one place, talking to just the people that are around you, and voluntary response. People are volunteering to be part of the study. And so if you're talking about oranges that are in a crate, it's kind of difficult for oranges that are in a crate to volunteer to be part of a study. And so this sampling would be a convenience sample. And so the ways that a convenience sample in this case could lead to bias is you have to think about the perspective of the farmer. The farmer is probably going to put his best stuff on top. And so this could lead to bias because this could lead the inspector to think that the oranges on the top are of better quality than they really are. And so, or that the whole thing of oranges are of better quality than they really are because of the oranges on top. Your second example says the ABC program Nightline once asked whether the United Nations should continue to have its headquarters in the United States. Viewers were invited to call one telephone number to respond yes and another for no. There was a charge for calling. There was a charge for calling either number. More than 186,000 callers responded, and 67% said no. All right, so if you were thinking about this program Nightline, they are inviting people to call one telephone number to respond yes and another for no. And so this is what we call a voluntary response sample. Anytime that you are inviting someone to respond, that's a voluntary response because they can decide to respond or to not respond. And so you kind of have to think about the people that are responding probably feel particularly strong about the issues, and so they are likely to respond, more likely to respond than someone who's kind of apathetic and doesn't really care. So we talked about how you sample badly, and so now we're going to talk about how you sample well. And so the best way, or the first way that you can sample well, is through a simple random sample, which you will see abbreviated as SRS. Now keep in mind that this is a simple random sample. So a simple random sample of size n consists of n individuals from the population chosen in such a way that every set of n individuals has an equal chance to be the sample actually selected. And so this would be like making sure that everybody has an equal chance, that like if you were drawing names from a hat, that everybody's name is only in there once. You don't have somebody whose name is in there 3 or 4 times. So there are a couple ways that you can get a simple random sample, and one of those ways is through a table of random digits. And so a table of random digits is a long string of the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 with these properties. Each entry in the table is equally likely to be any of the 10 digits 0 through 9. The entries are independent of each other. That is, the knowledge of one part of the table gives no information about any other part. And so we're going to talk now about how you choose an SRS or a simple random sample using Table D. Table D is given to you. You will always have that, and it is always used to find a simple random sample. So your step one is to label. So each member of the population is given a numerical label of the same length. So you got to make sure that, like, if you're numbering people, that everybody gets like a 2-digit or a 3-digit number. So it's not like one person gets a 1-digit and one person gets a 2-digit. Step 2 is to look at the table, and so you're going to read consecutive groups of digits of the appropriate length from Table D. And so this is going to be maybe a little bit confusing to you, but your table is going to look like this. So this is, this one says Table B, but Table D, Table B, this is just one table from a book somewhere. Anyway, this is what it looks like. And so you see that you have these numbers over here are your line numbers. And so sometimes your sample will tell you use the simple random sample table to choose a simple random sample. And so they may tell you look at line 110. And so if they tell you to look at line 110, you would be looking at these numbers right here. I don't know why I highlighted this one. Forgive me. Go away. Oh my gosh. All right, so when it says read consecutive groups of digits of the appropriate length, so we talked in step 1 about making sure that you give each member of the population a numerical label of the same length. So if we were saying 2 digits, then what we would do is we would go to line 110 and we would look at 2-digit numbers. So you have, like right here, you have 38. So that would be a 2-digit number. Then you have 44. There's another one. And then you have 8 and this 4, which makes 84. If you were doing 3-digit numbers, you would say your first number would be 384. And so once you have gotten the things from your table that you need, then your sample contains the individuals whose labels you find. So your first example that kind of goes along with Table D is the school newspaper is planning an article on family-friendly places to stay over spring break at a nearby beach town. The editors intend to call 4 randomly chosen hotels to ask about their amenities for families with children. They have an alphabetized list of 28 hotels in the town. And so it's important that they have alphabetized this list because then you know, like, the one that starts with A is going to be the first one. Does that make sense? I hope that makes sense. All right, so you're going to use Table D at line 130 to choose a simple random sample of 4 hotels for the editors to call. So you're only going to look for numbers that are between 1 and 28. So it looks like we are going to be given each of the hotels a 2-digit number. So the first one would be 01, the second would be 02, and it would go all the way to when you had 27, and then you had 28. And so we're going to go back to our table, and we're going to go to line 130, just like it told us, and this is line 130. So what we're going to do is we're going to go through and choose 2-digit numbers, and the 2-digit numbers that we chose, the first 4 of them are going to be the hotels that they're going to call. So 130. So we have 69. 69 is not a number that is included in the list of 28 hotels, so that one's out. Then we have 05. So you would call the 5th hotel on the list. And then you have a 1 and a 6. Well, this is going poorly. You have a 1 and a 6, which means that you have 16. There we go. Then you have 48. So you already have 2. You have 5 and you have 16. All right, so then you have 48. 48 is not in between 0, 1, and 28, so that one's out. But then you have 17. 17 is between 0, 1, and 28, so 17 is your third one. And then you have 87. We can skip that one because that doesn't fall between the numbers 0, 1, and 28. Then you have 17 again. We can skip that one because we've already chosen that one. Then you have 40, which makes 40. That one's out. 95 is out. There's another 17. Got to skip that again. 84 is out. 53 is out. 40 is out. 64 is out. 89 is out. 87 is out. But then there's 20. So there is your fourth one. So what you would do once you got those numbers is then you would go to your list of your hotels, and remember each one of those has a 0, 1, 0, 2, 0, 3, all the way to 28, and you would say, okay, I'm going to choose 0, 5, 16, 17, and 20. Another way that you can choose a simple random sample is on your graphing calculator. And so you are going to use a TI-84 Plus for this class. And so I have one of those on my computer here. And so what you're going to do is you're going to go to the Math button, which is right underneath the green Alpha button. Once the Math button comes up, you're going to scroll over to where it says PROB. That's your probability. You're going to choose a random integer, so you're going to choose option 5. Your lower is going to be as low as it can go, which would be 1, and your upper is 28, and then you just hit enter, 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 enter again, and it gives you a number. So our number is 15, so 15 would be the first one that we would choose. All right, all you have to do is hit enter again. It gives you another one. So 12. Enter again. There's a third one, 21. Enter again, 2. So what you've done is you told your calculator that you're going to choose a random number between 1 and 28, and then you can hit enter as many times as you want to, and it's going to give you a random number. Just like we did in the last one, each of these numbers would be associated with a hotel name, and so you would go to your alphabetized list of hotels, you would look at the 15th hotel, and that would be one of your choices. Other sampling methods. So another sampling method that we have is a stratified random sample. And so even though this one has the same letters that a simple random sample does, we never abbreviate stratified random sample as SRS. So anytime you see SRS, we're talking about a simple random sample, not a stratified random sample. So your stratified random sample is you're going to first classify the population into groups of similar individuals, which we call strata. Then you're going to choose a separate SRS, simple random sample, in each strata, and then combine the simple random samples to form the full sample. So that may sound really, really, really odd, but you will get that here in a minute when we do an example. Basically, what you're doing is you're taking your population, you're going to break it down into, say if we were talking about students at East Rutherford, we might break it down into males and females. And so our two strata would be males and females. And then we're going to choose a separate simple random sample within each of the stratum. So like a simple random sample between the males and a simple random sample between the females. And we would combine those to form the full sample. So it would be like choosing males and females, but not doing it from the entire population, breaking it down first so that we can make sure that we have like the same number of males as we do females. If we just had the full population and we just did a simple random sample of everybody, we might get more males than females, and that may just be how it works out. But to do a stratified random sample means that we're kind of restricting our number of males and our number of females. A cluster sample. A cluster sample means that you're first going to divide the population into smaller groups, just like you did it in a stratified random sample. Ideally, these clusters should mirror the characteristics of the population, and then you'll choose a simple random sample of the clusters. All individuals in the chosen clusters are included in the sample. So now it's time to practice the 3 sampling methods we just discussed: simple random sample, stratified random sample, and cluster sample. So the way that we're going to do this is with this example about the sampling at a school assembly. So it says the student council wants to conduct a survey during the first 5 minutes of an all-school assembly in the auditorium that uses about the use of the school library. They would like to announce the results of the survey at the end of the assembly. The student council president asks your statistics class to help carry out the survey. So your problem is that there are 800 students present at the assembly. A map of the auditorium is shown below, and that the students are seated by grade level, and that the seats are numbered 1 to 800. So you kind of have this picture of what's going on here, and then it tells you that you have your grades divided into the seats that they're in. So like all the 9th graders are sitting between 601 and 800, all the 10th graders between 401 and 600, and so on and so forth. So what you're going to do is decide how you would use each of the following sampling methods to select 80 students to complete the survey. So you have, for A, you have a simple random sample. Well, remember, a simple random sample means that you take your entire population and you choose from that population however many that you want. And so what we would do for a simple random sample, you have 2 ways to do a simple random sample. That would be using the table or using the random number generator like we did on the calculator. And so probably the easiest thing to do is to use the calculator. So what we're going to do is, remember, each student has a seat number. So you're going to have a random number generator, and we're just going to use our calculator. So we're going to do rand int. Your lower bound is the last, or like the, I guess in this case, the first seat number, which would be 1. And your upper bound would be your last seat number, which would be 800. And because we're choosing 80, that's what our n is going to be, and I'll show you where to find that too. So you go to your calculator, you go to math, you go to PROB, that's your probability menu. In there you'll choose your random integer, which is 5. Your lower bound is going to be 1, your upper bound is going to be 800, and your n here is going to be the number that you're choosing, which in this case is 80. And so then you just hit enter, and what you're going to find is it's going to give you this list of numbers, and you could go through and count them all if you wanted to, but there are 80 of them. And so these are the seat numbers that you would choose. So what you might do is, like, your person that's in charge of your assembly would call these seat numbers up. Those people would all gather together to ask your question. B, so this is a stratified random sample. Remember, a stratified random sample means that you break your population down into groups, and then from those groups you do a simple random sample, and then you put them all back together. And so one way that might be easy for this example is you already know that all the grade levels are sitting together, so your strata might be best to use your strata as your grade levels. And so the reason that is because if you kind of think about it, you might figure that your library use is probably the same in the grade levels, but not across the grade levels, if that makes sense. So for example, like the seniors might use the library more than the freshman class. And so it might be a good idea to take a group of seniors and survey them, take a group of juniors, take a group of sophomores, take a group of freshmen, and to survey them about the library, and then go from there. So the way that you would do this is your strata would be your grade levels. And for each of these grade levels, you're only going to choose 20 students from that grade level. And the reason that you're doing that is because you want a total of 80. So you've got the 4 grade levels, and so obviously that would be 20 apiece. So the way that you'll do this is you'll go to random integer again on your calculator, and let's say that you were doing a simple random sample of the freshmen. Your lower bound would be 601 because that is the first seat that your freshmen are in. Your upper bound would be 800 because that's the last seat that your freshmen are in, and you're going to choose 20 of them. This is for the 9th grade. So you can do that on the calculator just like we did in the last example. If you were doing the 10th grade, you do the same thing. So you do random integer, and you would choose 401 as your lower bound and 600 as your upper bound. You're choosing 20 of those students. 11th grade, you do the same thing with your lower bound as 201, your upper bound is 400. And for 12th grade, your lower bound would be 1 and your upper bound would be 200, still choosing 20. C, for a cluster sample. With the way that the students are seated, each column of seats from the stage to the back of the auditorium could be used as a cluster. So for example, if you notice in the first column here, you've got 1, you've got 21, you've got 761, 781. Obviously there would be rows in between that. They were just kind of giving you an idea of what it sort of looks like. So you can see that they all end in 1 basically. And so you could use that as your clusters. Note that each cluster contains students from all 4 grades. So if you think about in your 9th grade section, you have, or in your 12th grade section, you would have 1, you'd have 21, you would have, in your, let's see, where would this be? This would be your 9th graders. So you would be taken from that column, you would have some freshmen, some sophomores, some juniors, and some seniors. And since there are 20 clusters, each with 40 seats, we need to choose 2 clusters at random to get 80 students for the survey. So you would use the random integer again, using 1 as your lower bound and 20. 20 because there are 20 clusters, so there's like 20 different columns basically in your auditorium. And then you would give that survey to all of the 40 students in each column of seats. The manager of a sports arena wants to learn more about the financial status of the people who are attending an NBA basketball game. He would like to give a survey to a representative sample of more than 20,000 fans in attendance. Ticket prices for the game vary a great deal. Seats near the court cost over $100 each, while seats in the top rows of the arena cost $25 each. The arena is divided into 30 numbered sections from 101 to 130. Each section has rows of seats labeled with letters A, nearest to the court, to ZZ, top row of the arena. So if you're thinking about this stadium, you might, or it's important that you think about the number sections and how those numbered sections includes seats that are over $100 all the way down to seats that are $25 each. So those sections are pretty representative of the types of people that are there. Just keep that in mind. So on number 1 it says, explain why it might be difficult to give the survey to a random sample of 200 fans. So one reason that it might be difficult to give a survey to a simple random sample of 200 fans is the fact that if you're using like a number generator or using the table 200 fans, you are going to be talking about 200 different people that are sitting in different places throughout the arena. And so it might be difficult to get to all of those 200 fans at one time, throughout the game. You always run into the risk of someone maybe not being in their seat, or there being someone who's not there for some reason, like if you had someone that was a season ticket holder and they didn't come to every game or something like that. Number 2, Which would be a better way to take a stratified random sample of fans, using the lettered rows or the numbered section as strata, and explain. Well, if you think about the lettered rows mean that they are going to be, all the seats on that row have the same letter, which mean all the seats on that row would have cost the same amount because they're the same distance away from the court. The numbered sections, however, have different rows within them, and so each of those rows all have different prices depending on their distance to the court. So the better way to take a stratified random sample of fans would probably be to use the lettered rows as a strata, because each lettered row is the same distance from the court, and so they would contain only seats of the same or nearly the same ticket price. And so this means that all the people in any given strata would probably have paid roughly the same amount for their tickets. So number 3 says, which would be a better way to take a cluster sample of fans, using the lettered rows or the numbered sections as the clusters, and then explain. And so if you were thinking about the numbered sections as clusters, those would be, remember, they would represent people that paid over $100 all the way to people that paid just $25. However, the lettered rows would have people in it that paid roughly the same amount because they're closer, because of their proximity to the court. And so the best bet is probably to use the numbered sections as the clusters, because they include all different ticket prices. Each section contains seats with different ticket prices, so the people in a section would mirror the characteristics of the population as a whole. Sampling surveys. What can go wrong? So there are 3 things that can definitely go wrong whenever you're doing a sampling survey. And when we talk about things going wrong, we just mean that you're not getting a full picture of your population. And so the first is undercoverage. Undercoverage occurs when some groups in the population are left out of the process of choosing the sample. So for example, whenever the census is done, questions are asked by either going around to people's homes and making phone calls to people that live in houses, or through the mail. And so people that are undercovered during the census are people that are homeless or live in hotels or don't have stable home lives. Non-response is another way that sampling surveys can go wrong, and this occurs when an individual is chosen for the sample but cannot be contacted or refuses to participate. So this is like the opposite of voluntary response. And response bias is a systematic pattern of incorrect responses in the sample. So an example of this would be having to do with the wording of a question. If the wording of a question is worded in such a way that people aren't really sure about the question that's being asked, this can produce response bias, which is what we're going to look at in the next example. So in the next example, it says, how do Americans feel about illegal immigrants? So question wording matters. We sort of touched on that just a second ago. But it says, should illegal immigrants be prosecuted and deported from being in the U.S. illegally, or shouldn't they? Asked this question in an opinion poll, 69% favored deportation. But when the very same sample was asked whether illegal immigrants who have worked in the United States for 2 years should be given the chance to keep their jobs and eventually apply for legal status, 62% said that they should. So compared to the 69% that said they needed to be deported, 62% said that they should be given an opportunity. And so different questions give quite different impressions of attitudes toward illegal immigrants. So if you were wording a sample or a question that is going to be asked to a sample, be sure that you ask it in such a way that it doesn't it's not confusing, and it doesn't make people feel like you want them to lean one way or the other. So check your understanding. Remember, you're going to answer this question that shows up after I read the example. So it says, each of the following is a source of error in the sample survey. Label each as sampling error or non-sampling error and explain your answers. So the first one is the telephone directory is used as a sampling frame. So when we talk about a sampling frame, this means that these are the people that you plan to survey. So the telephone error being, or directory being used as a sampling frame is sampling error. This will result in undercoverage of those who are not listed in the phone book, or those who do not have a telephone or only use a cell phone, and so those people would not be given the opportunity to participate. B, the person cannot be contacted in 5 calls. If a person has tried to be contacted but cannot be contacted in 5 calls, we call this non-sampling error. And it doesn't necessarily have to do anything with the person that's doing the survey or anything like that. It just occurs because the sample was chosen, but rather was an effect of the way that the survey was administered. So maybe if you had sent a letter to that person instead of calling them on the phone, they would have been more likely to respond. C, interviewers choose people walking on the sidewalk to interview. So if interviewers are choosing people who are walking by on the sidewalk to interview, this is what we call convenience sample. So these are people that are just very close by and you can grab them and ask them. This would be an example of sampling error because there of course are people that are not going to be walking on the sidewalk, that may be driving in a car, those kind of things that are going to be left out. But also it's going to kind of depend on the neighborhood that you're in or the area that you're in. It's going to be kind of hard to survey people that are walking on the sidewalk in Golden Valley, but it wouldn't be as hard to interview people that were walking on the sidewalk in Forest City or in Ellenboro or Rutherfordton or one of the bigger small towns that we have here in Rutherford County. 2, a survey paid for by makers of disposable diapers found that 84% of the sample opposed banning disposable diapers. Here is the actual question. It is estimated that the disposable diapers account for less than 2% of the trash in today's landfills. In contrast, beverage containers, third-class mail, and yard waste are estimated to account for about 21% of the trash in landfills. Given this, in your opinion, would it be fair to ban disposable diapers? And so then I ask you to explain how the wording of the question could result in bias, and be sure to specify the direction of the bias. So basically what happens is by making it sound like disposable diapers are not a problem in the landfill, this question will result in fewer people suggesting that we should ban them. Because whenever you hear that disposable diapers only account for less than 2% of the trash in the landfill, you kind of think, well, that's really not that big of a deal. The author of the question highlights several other items that take up more space in the landfill, which kind of makes you think that the disposable diapers aren't really a problem, but we should think more about beverage containers or third-class mail or yard waste.